Hello, I wish you are fine. So I want to speak of a single-stage CO2 refrigeration system in English. Why in English? Because my students have to make a presentation in English and they are afraid of speaking English. So I want to show them that it's possible. The most important is to be understood. So let's start the refrigeration presentation. Donc, this is a CDUS Sanden unit, and you can see it on the picture. And when you remove the hood of the system, you find the parts. You will find the compressor, the gas cooler, the electronic expansion valve, and in the cold room you will find the evaporator. Here you can see an expansion valve, but there is no expansion valve. And after you will go back, the gas goes back to the compressor, and here you have a suction bottle. On the diagram you can see also the points of the cycle. The point 1, suction point, the point 2, discharge point, the point 3, behind the gas cooler, the entry of the expansion valve, the point 4, the entry of the evaporator, and the point 5, the exit of the evaporator. So now you can trace the cycle on the CO2 diagram. So you can see that it's not a subcritical cycle, but it's a transcritical cycle. In summer, the temperature is high, the outside temperature is high, and your system will work in transcritical cycle. So you have in transcritical cycle you will have the HP near 90 bar, and the LP it's the pressure at your evaporating temperature. So the point 3 is the exit of your gas cooler, and at the exit of your gas coolers you are at the HP, and the temperature is near 35 degrees if it's 32 degrees outside. So you have your point 3. So after the gas goes through the expansion valve, so there is a drop pressure, and you will obtain the point 4. And the gas goes, the CO2 goes through the evaporator. You have CO2 evaporation between 5 and 4, and then the gas goes back to the compressor. You have the point 1, and the compressor compress your gas, and you obtain the point 2. So when you have traced the cycle, if you know the sub-volume of your compressor, you will find the power, the refrigeration power of your system. I know that the compressor displacement is 4.8 cubic centimeters, and I know that the compressor speed is between 0 and 5,400 revolutions per minute, if the frequency is between 0 and 90 Hz. So now I can find the power. So let's see the data of Sanden. And they say you that at minus 5 degrees of evaporation temperature, if the outside temperature is 32 degrees, and the speed of your compressor is at 80 Hz, the system will give you about 3.3 kilowatt of refrigeration power. So I wish you a good day.